In this video, we'll be learning how to graph logarithmic functions. So typically when we graph a function, we start off by creating a table of values in order to have some points to graph for that particular function. Now with a logarithm, this is a little bit more difficult because, say for example, we wanted to create a table, from -2 to 2. So say we wanted to do that. So let's start with -2. If we start, we're going to take, we're going to plug in -2 for x. Okay, now if we use the little exponential to logarithm trick, we can rewrite this as -2 to the power of y equals 3. And I don't know about you, but I don't really know what number, if I take -2 to a power, equals 3. So creating a table of values really isn't that simple here. So we're going to have to do something a little bit different, as just plugging in -2 to 2 doesn't quite work. Now what we can use instead here is we can use our knowledge of inverses. So we know that logarithms and exponentials are inverses of each other. What we also know is that inverses have x and y values that are essentially flipped in their table. So if we can find the inverse function of, y equals log base 3 of x, and we can find a table of values for that function, essentially what we can do is we can just flip the x and y's, and that will be a table for y equals log base 3 of x. So here, if we find the inverse, so let's do that here. So let's find the inverse of this logarithm. So remember, when we find the inverse, we flip x and y. So we have x equals log base 3 of y. And then we solve this equation for y. So here, what we're going to do is we're going to rewrite this as an exponent because we know we can rewrite logarithms into exponents. So we have 3 to the power of x equals y. So if we rewrite this with the y first, we have y equals 3 to the power of x. So what we know is that log base 3 of x and 3 to the power of x, those two functions, are both inverses of each other. So essentially, if we can find a table for this function, we can just flip-flop the x and y in those tables, and we'll then have a table for log base 3 of x. So let's try that out. So if we find a table for y equals 3 to the power of x. So I can do that pretty easily. If I take -2, -1, 0, 1, and 2, and substitute those into the power of x for 3, so that becomes 3 to the power of -2 for the first one, which I know turns into 1 over 3 squared, or 1 over 9. You can also use a calculator here if you would like, so that would be about 0.1 repeating. Then if we take 3 to the power of -1, that's going to be 1 over 3, which is about 1/3, or 0.3 repeating. We then take 3 to the power of 0. Anything to the power of 0 is 1. We then take 3 to the power of 1, which is 3. And then we take 3 to the power of 2, which is 9. So we've got 3 and 9. So here we've got a table of values for our exponential. Now what we can do, because these are inverses of each other, is we can create a table for y equals log base 3 of x by essentially just flipping those x and y values around, because we know that's a property of inverse functions. So here this would become 1/9 and -2, 1/3 and -1, 1 and 0, 3 and 1, 2 and 9. So all we need to do is find the table for the inverse function, and then we can actually use that to create a table for our logarithm. So that's what we'll be doing today as we graph these functions, is we'll be using our knowledge of inverses to help us create a table for the logarithmic function, and then we'll be graphing those onto the coordinate plane. So let's try our first example here together. So let's start by finding the inverse function, as we know that creating a table of values for the logarithmic function can be a little bit difficult. So here we flip x and y, so log base 4 of y, and then we use our knowledge of rewriting a log into an exponent to solve for y. So this becomes 4 to the power of x is equal to y. So we just have y equals 4 to the power of x. That's our inverse function for log base 4 of x. So if we create a table of values for that, we type in values from -2 to 2. As we do that, 4 to the power of -2, well, that becomes 1 over 4 squared, which is 1 over 16. Or if you do that in a calculator, it would be something like 0.0625. We then take 4 to the power of -1, which is 1 over 4 to the first, which becomes 1/4, or 0.25. 4 to the power of 0 is just 1. 4 to the power of 1 is 4. And 4 to the power of 2 is 16. So we have our inverse function here in a table of values. So that is going to help us find a table of values for our logarithm, because all we need to do in order to find that is to switch the x and y, because inverse functions essentially are a reflection over that origin line, and they have opposite x and y values. So here we would have a y value of -2 and an x value of 1/16. So notice they get flipped. Then we have 1/4 and -1, 1 and 0, 4 and 1, 16 and 2. So let's go ahead and try to plot those. So I'm going to focus on using the y values here first and then finding the x values. So if I have -2 for my y value, and then I have 1/16, so that's going to be a pretty tiny number right there. Then I have -1 for my y value and 1/4, 0 for my y value and x is 1, 1 for my y value and x is 4, and 2 for my y value and x is 16. So this is going to curve pretty steeply right here. Now I noticed these were getting super tiny decimals, so it's going to look something like that. So what this should look like is it should look like the exponential swoosh that we saw with exponential graphs, but now it has been flipped around because these are inverse functions and the x and y values are flipped. So just like we used to have a horizontal asymptote right here at the x-axis for our exponential functions, inverse functions actually have what's called a vertical asymptote here at the y-axis. So if we're finding our domain here, notice that this graph does not go forever left and right. Instead, it's got this imaginary asymptote line that it cannot cross. You can see that there it's getting very close, but not quite crossing. So my domain is going to be x is greater than 0. And my range is going to be going forever up and forever down because it's curving forever up and forever down. So we have a range of all real numbers. So you should be noticing that the domain and range are kind of similar to exponential functions, but they are also in reverse, just like the tables are the x's and y values in reverse. So let's go ahead and give another example a try. So here we're going to graph the natural log function, and we're going to do so by, again, using our knowledge of inverses. So remember, a natural log is a base of e. So if we use our knowledge of the inverse function first, we're going to flip x and y. So we have e equals natural log. I'm going to write my base e in there so I remember that it's base e. And then I can rewrite this into an exponential by taking e to the power of x is equal to y. So we're going to create a table for y equals e to the power of x. So if we take -2 to 2 and plug those into a calculator, because e it isn't so nice to just do in our heads, we have 0.135 for -2. Then if we plug in -1, we have 0.368. Then if we plug in 0, we get 1. If we plug in 1, we get 2.718. And if we plug in 2, we get 7.389. So that's our table for our exponential function. And then we can create a table for our natural log function by just flipping those around. So here we have 0.135 and 2, 0.368, oh, sorry, that's a -2 up there, and -1, 1 and 0, 2.718 and 1, 7.389 and 2. So now if I start to plot these, so -2 and then x is a really tiny number, so there we go, -1 for y, and then x is just about 0.3. Then we have 0 for y and x is 1. 1 for y and x is about 2.7. 2 for y and x is about 7.3. So we can see it's got that same swoosh shape, but it's curving upwards. So we've got that same swoosh curving upwards. Now here we have a domain that is x is greater than 0 because all of the x values are greater than 0, but they don't quite go into that negative range because remember there is a vertical asymptote right here. Then we have our range, which is going forever up and down, so we have all real numbers.